Hello, PCH students. Here we are with the laws of logarithms that you learned way back in Algebra 2 Honors. We got the product rule. The log of a product is the sum of logarithms. Quotient rule. The log of a quotient is the difference in logarithms. Power rule, otherwise known as the bump the log rule. The log of an exponential brings the power of the exponential down in front as a multiplier. And this idea that basically you can undo the logs if it's the same base. Log base b of m equals log base b of n if and only if m equals n. Also, we've got these variations. B to the log base b of x equals x, and log base b of b to the x equals x. These are based on the idea that these two functions are inverse functions of each other. So when you nest them within each other and put b to the x inside the log base b function, it'll end up undoing each other and you're back to x. Now here's proving one of the power rules, bump the log rules. There's a nice proof of the addition rule in your text, of the product rule in your text. And I use that product rule in this proof. We start up by writing out m to the k as a bunch of m's multiplied together. Log base b of m times m times m times m times n, dot, 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 and so forth, k times. So we can apply the product rule to that. So it's log base b of m plus the log base b of m plus the log base b of m plus the log base b of m plus k times. So we're adding up something together k times. So that's a definition of multiplication. That's k times the log base b of m, or k times the log base b of m. Now here's example 1. Express log base b of mn squared in terms of log base b of m and log base b of n. So log base b of mn squared, first I'm going to use the product rule. The log of a product is the sum of logarithms. And now I use the bump to log rule, or the power rule, and this power comes down in front. 2 times the log base b of n. There you go. Now express log base b of the square root of m to the third over n. I'm going to start off by changing this to m cubed over n all raised to the 1/2 power. So they can see that I can use the power rule here. It'd be 1/2 the log base b of m cubed over n. And now I can use the quotient rule. The log of a quotient is the difference in logs, the log base b of m cubed minus the log base b of n. And finally the power rule again, 3 times the log base b of m minus the log base b of n. So I've broken it down into just terms of log base b of m and n. Simplify log of 45 minus 2 log of 3 without a calculator. Well, we can first use the power rule to get this 2 inside as a power. So it's the common log of 3 squared. So it's the common log of 45 minus the common log of 9. Now I can use the quotient rule. A lot of kids mistakenly use the quotient rule on this right away. You can't. Because the quotient rule says you've got a difference of logs. You got a log minus twice another log here. So I had to get that inside first. That becomes the log of 45 ninths, which simplifies down to the common log of 5. Express y in terms of x if the natural log of y equals 1/3 natural log of x plus natural log of 4. Well, I'm going to use the idea that if I can get 1 log on each side, then I can set the insides equal. So that's my goal. We're going to start by getting this 3 1/3 inside as a 1/3 power. And now I can use the product rule in reverse to write this as 1 logarithm. X to the 1/3 times 4. So I've got the natural log of y equals the natural log of 4 times x to the 1/3. So now basically I'm taking the inverse log of both sides to get y equals 4 times x to the 1/3 power. Example 5. Solve this equation. Well, let's take a look here. Don't just zap these log 2's. You can't divide both sides by log 2. If you do that, I will rain thunder and lightning upon your parade. What we can do, though, is write this as 1 logarithm using the product rule. X times x minus 2 equals 3. And now this is the log base 2 of x squared minus 2x equals 3. And now you can rearrange it from the definition of what a log is. A log is the missing power. This log is 3. 3 is the missing power between these two. So 2 cubed equals x squared minus 2x. So we have a whole new problem here now. Let's get the split screen. X squared minus 2x equals 8, or x squared minus 2x minus 8 equals 0. So this factors happily at x minus 4 times x plus 2. And so you get x equals 4, or x equals negative 2. But wait, you cannot take the log of a negative number. So we have to check our answers back here in the original equation and see if any of these will make the log negative. And sure enough, if I put a negative 2 into x, that makes log base 2 of negative 2, undefined. Negative 2 into here, negative minus 4, undefined. So we have to throw out negative 2 and just keep this 4 answer. If we put 4 in, it's log base 2 of 4, which is 2. Log base 2 of 4 minus 2 is log base 2 of 2, which is 1. 2 and 1 is 3. Checks out. Now we're going to go back to writing things as a single log. How do we compress this into one logarithm? Well, the 5 out here, I don't want to distribute it yet. Let's compact this into log base b of ab minus, and let's move this one inside, log base b of c, 2 times log base c of c. Now I can move these coefficients outside the log, inside the log as powers. So log base b of ab to the 5th minus the log base b of c squared. So it becomes log base b with the quotient rule now of ab to the 5th over c squared, or the log base b of a to the 5th b to the 5th over c squared. There we go. Now, I think, as you notice, we're already in the homework examples now, so if you feel confident to start the homework, go ahead. I want to try a couple more of these log inequalities. And these rely on the idea that the log functions are one-to-one. So basically, you're going to be able to undo the log from both sides of the inequality without affecting the nature of the direction of the inequality. So, again, don't just zap the logarithms. We're going to write this as one log. Log base 2 of x plus 5 times x minus 2 is greater than or equal to 3. And now we can rearrange it. And when we rearrange it, keep it in the same order. That is, I'm going to use both sides as a power of 2. So watch this trick here. I'm actually doing the inverse log base 2 of both sides, which is the exponential function, which looks like this. And since it's a one-to-one function, it's not going to change the direction of the inequality. So we get x plus 5 times x minus 2 is greater than or equal to 8. There, done the logs. And now it's one of your old friends. Unfortunately, some of you are still messing up on this. You've got to expand this out, factor it, and then look at it again. So this is x squared plus 3x minus 10 is greater than or equal to 8. And now we can look at this as x squared plus 3x minus 18 is greater than or equal to 8, greater than or equal to 0, sorry. This factors into x plus 6 times x minus 3. And let's take advantage of our knowledge of what this graph looks like. It's got roots at negative 6 and 3. It's a happy parabola. It's going to be positive on the outer edges here. So the solution is x is less than negative 6 or x is greater than 3. Now, you have to go back to the original equation to see if these violate our rules of not taking a log of a negative number. And any negative 6 or anything left of that is going to make this negative. It might make this positive in here, but you have to go back to the original equation. And here, since it makes those negatives, we're going to have to nix those out. And so we just take the solutions of x greater than 3 for a final solution. Now let's look at this one, log base 4 of x. It's similar. Again, don't divide through by log base 4. It is not a number. It's not multiplying by log base 4. It is log base 4 of x minus 1. So we start with the log base 4 of x minus 1 times x plus 1 is less than or equal to log base 4 of 6. And there's no need to basically calculate this out. Let's leave it like that, because we have the log base 4 of x squared minus 1 is less than or equal to log base 4 of 6. Now we can take the inverse log base 4 of both sides. So it's basically like using both sides as a power of 4. So that gives you x squared minus 1 is less than or equal to 6, or x squared is less than or equal to 7. This one we can actually do without a graph, because you can do this trick with taking the square root of both sides. Absolute value of x is less than or equal to square root of 7, so that puts x in between negative square root of 7 and positive square root of 7. The thing is, though, we have to be careful because there's domain restrictions. There's restrictions that x minus 1 must be greater than 0, x must be greater than 1, and x plus 1 must be greater than 0, x is greater than negative 1 from back here. Now this is the more constrictive one, x is greater than 1. So we're going to have to incorporate that into here and say, oh no, we can't use that whole range. It's going to have to be 1 is less than x is less than or equal to the square root of 7. And that's it. Flange out.
Again.
Video of that girl falling.
No, did they fall?
Yeah.
Tell me the story. She wiped out.
She like sprawled.
Oh my gosh.
It was really funny.
Yeah,
Oh, it did? Because you were in it?
I think it might be in the background.
Oh, it might be in the background?
Yeah.
I can help her sue the university, right? For
No,
damages?
no, she didn't trip over anything.
She tripped over.
It was flat.
You guys want to pose by your favorite fountain over there?
Yes.
Yeah, come on, Jack.
But don't actually get in it, kids.
Let's dodge it.
No, no. Living on the edge. Oh, see, and then there's the getting out. Oh, Jake. Oh, Jake. He's trapped. Oh.